Hey there! So today we'll be talking about spatial variables. Specifically, we'll start off with box-shaped spatial variables that set a specific value. So let's get right into it. To start off, we'll simply make a new box. Yippee! Then we're going to open up this box and we'll prepare it for working on it. So we'll give it a parent. We'll disable its collider and we'll grab the grabbable and move it into the parent. I'm then going to make a new slot here and call this area. And we'll click attach component and we'll put a data spatial box variable of type box constant value spatial variable. Now, I will be using integer for this one, but you can use pretty much any data type for this. Now, this is a lot of words, right? All you need to know is this component will set this variable here at this position, wherever that slot is, in this range. So the size is essentially the range in a box shape with this value. So basically, if I am at this specific point sampling in a range in a box shape of 1, 1, 1, I will receive the value 0 if I sample the variable name area ID. There we go. For example, the area the name area ID, I will receive 1. Now, it can be a little bit hard to conceptualize this if you start changing it to a size of 5. And now it's bigger than this box here, and you notice, because this is a box that's a scale of 1, so this one is like 5 times that size. That's a bit hard to actually just imagine. So what I like doing is I'll duplicate this box and put it underneath the area. We'll actually reset its position, rotation, and scale. And we'll actually give this its own material. So we'll go to materials, unlit, and we'll use a overlay unlit. We'll change the behind color to green and also the front tint to green. Our behind tint is going to be very transparent, and our in front of tint is going to be less transparent. Now we just changed the blend mode to alpha. So now if there's something blocking it, it's going to be essentially more dim, as you usually see with these kind of materials. The last thing we'll do here is we'll grab the -1 from render queue and we'll put that into offset factor, so that if it's sharing the exact same position with, for example, this box here, it's not going to flicker. Then we just put that into the mesh renderer of the box, and now we have a visualization for our area. Because one great thing about spatial variables is that this distance here, this 555, which I'll change back to 111, is actually in the local space at first of that object, which means that if I actually upscale this object, instead of still having a distance of 111 like this, it now actually has its area properly adjusted for the slot. This is different from something like, for example, the value distance driver, who, if you have a distance from here to here and then you make the box bigger, like here, the distance will still be from here to here because it's in global space where it actually checks the distance. All right, so next, we will actually be needing to somehow receive this value. The way we do this is something called samplers. So we'll go to create new, empty object, call this the sampler. Go to attach component, data, spatial, samplers, and we'll want the value spatial variable driver. Fancy word. All you have to know basically is it samples a certain point in space for a certain variable name, and then returns the value at that point. So in this case, we'll want to sample the variable name area ID, and our default value is going to be -1. Now, you have to be careful because, as you might have noticed, is this here and this here are both underneath two entirely different hierarchies. However, despite the fact that they are in fact underneath different hierarchies, if I make a data dynamic value variable of type integer, and then just grab the value here and put that into the drive, if I then just select our sampler here and move that into the area of this box, you'll see now that it's outputting 1, despite not being underneath the same hierarchy. This is because it's spatial. It is based on points in space rather than hierarchical like dynamic value variables. So if you don't make your names very unique, you'll run into the issue of eventually that you may cross-pollute with someone else's system. Now, what I'm going to actually do here is I'll expose the sampler's value in world space under world/area.active. Because one of the ideas that you could do with this is essentially culling. So now I have this in the world area.active space. So if I go back over here, I can make a new slot in the box parent. Call this areas. And we'll go to actually, no, let's do this differently. So you could use a Boolean switcher or anything like that to control this, but I'll actually just make a new area here by making a child. Go to attach component, and we'll add a transform drivers value equality driver of type integer. And then in this case, this is going to be area 1. So this will check against a reference 1 for the area ID. So in areas, we'll actually want a data value field integer and a dynamic value variable driver of type integer. And then we want the world area.active variable in here. So right now, that will give us -1 over there. If I move the sampler inside of the box, you'll see it'll change both here and here from -1 to 1. So then on area 1, with the equality driver, I can grab the value field here and put that into the target value. And then our target is going to be the active state of area 1. So now, area 1 is actually going to enable or disable based on if the sampler is inside of the area 1 area. The next thing here is that, well, we are currently not really disabling anything by doing that because area 1 doesn't have anything underneath it. So we'll grab our box that we started off making and we'll put that into area 1. So now if the sampler is outside the area, we can't see the box. If it's inside, we can see it. And the final thing we'll do is we'll go to this back to our sampler, go to attach component, transform, drivers, and we'll want a position at user. Position at user, there it is. We'll use the local user, and we'll set the position source to view. And we don't really need a rotation source, but we'll just also set it to view. So now if I walk into the box here, it makes a smaller box appear. If we then were to go to our area here and actually edit the scale of it to make it a little bit longer, And a little bit longer in this direction as well. You can see how that also just inherently adjusts the sizing here. Now, one thing you can actually do with this, if I reset the area, go. Oh, right. I was wondering where the box went, but yes, no, you can only see the box when your head is inside of this. So one thing you can do with this is that this box down here, actually, if you go into Gizmo options and then go to box mesh, has a modifier for changing the shape of the box. Now this shape will be written to this size here. What you can do is you can actually drive your spatial value variable box constant size with this box's box mesh size, which means that now if I adjust this mesh, it'll also adjust that. So I'll just change the box here to be back positioned at 0, 0, 0. There we go. Yeah, so as you can see, that now properly changes. I will, though, say that one problem with doing that is, as you may have just noticed, that if I change the box mesh and then size it this way, it'll actually offset the position. So you'll actually have to account for that because you don't have a offset value you can put into here. So ideally, if you are using the box meshes sizing to actually adjust the area, you probably want the box mesh component to be actually inside of the exact same slot. So if we now change this and then also move the mesh renderer over to the area to have our little visualizer. Now, when we actually go to Gizmo options and then box mesh and then change the scale, it's going to properly adjust the area so that we can enable and disable it by walking into it. And this makes it very easy to just, set up little culling zones. Here we go. And now that is my culling zone. And this is basically using no flux at all and just allows you to use integers like area IDs. You could use binary and just, basically based on what bit is enabled, you can enable specific areas. You could use an int 2 and have an XY position and then also enable nearby areas, which would need to use a little bit more code, but it's possible and it's very efficient. So yeah, I hope this was a helpful video, and I hope you have a good time with these new spatial variables. Have a nice day.